students, I am Arijit sir. Today I am going to discuss with you the mechanism the presence of nitro group affects the reactivity. Actually, how nitro group actually going to affect the reactivity of the system. Okay, so actually we have got three nitro groups. Say for example chloronitro groups. If we take, say, so this one is our parachloronitrobenzene, okay, and this one is our orthochloronitrobenzene, okay. And the last one I'm going to draw, this one is metachloronitrobenzene. Okay, now I'm going to show you with the structural mechanism how actually this nitro group affects the reactivity of this system. Okay, now first, in the first case, say for example this parachloronitrobenzene. Now what happens, students, in presence of say for example some bases, in the slow step it forms slow step. Now this base actually attacks in this position, okay, and this group forms the negative ion over here. Now actually after that it started to form these positions. Now you can see. Actually nitrogen is plus over here and this is a minus, okay. Now this minus moves from this point to this point. Now here you can see a negative ion is forming over the carbon attached with the nitrogen, and this is the very important point I am marking with point number 1, okay. And this one is very important point, you can see over here. Now actually after that it forms another one. Try to draw the steps, students, properly as I am showing it to you, okay, and this will going to help you in the exams also, okay. Now this negative ion forms over here and this will open up, okay. And next step I am giving it a step number 2, okay. Now in the next step it forms these are all same. Now actually this negative ion moves back and then again it forms double bond over here and then it will form the negative ion over here, okay. Now you can see these are all resonating forms. I'm marking it over as 3, okay. Now next what happens, student? Chlorine OH, here is a bond that had already formed. These are the minus and pluses over here. Now this minus is now going to move back and form a double bond over here, and then chlorine will get out of this system, okay. So it is going to form a compound say for example this paranitrophenol, okay. This is our paranitrophenol. Now here in this case this is our paranitrophenol, how it actually forms from the paranitrochlorobenzene to paranitrophenol, okay. Now next I am going to show you how the mechanism works for the orthochloronitrobenzene, okay. A similar step, this very similar step, this which will attack over here and this double bond will come to this position, okay. Now similarly here in this case also will form the similar type of structures. Okay, now here you can see this is the minus forming over here. Okay, now this minus will push back to form this double bond over here, and then it will move back. Say form this one is point number 4. Say for example this one is what 5. Okay, now okay, now here in this case the double bond will move back to form like this. This is our point number 6. Okay, now in the next case, the next phase, it will form. See the difference, student, how actually I'm drawing it out for you. Just see the difference. The plus sign over nitrogen is always constant, but here the oxygen is not going to push back from the nitrogen group. Okay, this is number 7. Here is our negatives. Now this negative will push back over here and it will form the negative over in this position. Okay, now in the next step I'm drawing it for you over here. It will be easier for you to draw. So chlorine is here, which is over here, and the minus has already come over here. This is our number 8. Okay, this is our double bond, and this is how actually nitro group is situated. Now this minus will push back over here and chlorine will get out of the system, and then it will form after that our required compound is orthonitrophenol. Okay, and this is our orthonitrophenol, actually how it forms. This is our paranitrophenol, this is our orthonitrophenol. Now students, I'm going to do it for the metanitrophenol. Now similar case, metanitrophenol, which will be attacked over here, and then it will form the negative ion over here. Now see, now the negative sign comes from here. This is our point number, this is our 9. Okay, now here in this case I'm going to tell you at the very last how actually the reactivity order system actually prolong over here. I can see it moves over here, and then it will become negative point over here. Okay, now the negative is over here. I can see the nitrogen attached with the carbon. It is that carbon is not going to get any negative sign. Okay, and that will become the difference between these two others. Okay, now here it comes and it will form, this is our 10. Now next you can see and this will move over here and we will get out the system. This is our 11. So it will going to form this compound. This is our metanitrophenol. Okay, now students, actually what is the basic difference I'm going to tell you over here by showing these all resonance hybrids. You can see I have already shown you the mechanism how it actually forms. In these above structures showing the NO2 at meta position, you can see there is no such structure in which the negative charge is present on the carbon atom. Okay students, this is the main thing I'm going to tell you over here by showing all this resonance hybrid structure. The no negative charge is present on this carbon atom bearing the NO2 group. Therefore, the presence of NO2 group at meta position doesn't stabilize the negative charge. Okay, hence no effect on reactivity is observed by the presence of NO2 group in this meta position. Okay, so the change that actually takes effects in the ortho and para position, not in the meta position, because I've already told you no negative charge actually present on the carbon atom bearing the nitro group. That's why. Okay students, so you should understand. Next time in another mechanism I will bring you some of the systems, okay, for you. Okay, so do subscribe my channel and don't forget to share with your friends. Thank you.